So in the last video we talked about conditionals, and I think it's about time that we look at loops today. So what I'm gonna do now is basically say, what if we're gonna do a loop now, and the loop is gonna enable us to, instead of printing like 1, 2 and all the way down to 10 every time, or you want to repeat some instruction or keep executing the same, calling the same method, you know, or keep asking the same question with conditionals, you can do something called a for loop. This is the actual syntax. I'm going to put it here, and the syntax is called the what is this called? The first one is called the init, the initialization area. This is called the condition area. And the last one is called the incremental or decremental area. So in the init area, we can create variables like an integer, give it some initial value, call it I. It's a typical variable name, set it equal to 0, and say if I is less than 0, then we can say that I plus plus, which is a new operator you haven't seen before. Plus plus basically means that add 1 to the value of I. So if I is equal to 1 plus plus, now it's 2. So what I can do here now is basically say print out line and put in the I, execute the program, and now we will see that I write out 0 to 9. What is easy now is just say multiply by 2, and then we have another multiplication factor table of 2, and so on and so on. This is pretty easy, pretty boring stuff you're gonna do in your school. Now what probably the many teachers will not tell you is that in the starter, they will tell you eventually, but I'm gonna tell you now, is that with loops you usually don't do these kind of things you will learn in school, like printing out numbers and stuff like that. It's very normal that you use loops to iterate over data. So let's assume that you have a lot of data, and with that data you need to loop through all the names in the archive. Alright, so some real example, if you have an archive with lots of names, you need to look through all of them. So let's create an archive. So let's create something called a which one are we gonna use? The let me just see. We will use the Arraylist today, and we're gonna call it like archive. I cannot spell. Archive of names, I guess that is the right way. I'm gonna set that equal to a new Arraylist, basically just like that. Now, as we discussed before, whenever we have a declaration of a variable, we have type, name, assignment. This still applies here. So we have the type of Arraylist. The name is, you know, basically anything you want to give it. And then you have the assignment of a new one. So whenever you create a variable, think of a variable as an empty box, an empty container, something without value. And then whatever you're going to put inside of that is on the right side of the equal sign, which is the assignment, and that is a new Arraylist. I know it might be confusing, but in object-oriented programming, your variables is not equal to anything before you set them equal to anything. So if that helps you a bit, that's going to be the explanation for now. So what I can do is like I say, take this here and you say dot add, and then you can add on, let's say, names like Daniel. Then you could add another name, let's say it's Julie, and then you can add on last name, let's just say add again, and it's gonna be Luis. So what you're gonna do now is you're gonna use this loop to loop through this list. It's an iterational operation. So there are many ways to do that in Java, but let's for now just focus on this one loop called the for loop. It is the best loop there is. It can do everything. It's an all-purpose loop, and depending on the teacher, you might learn something called a while loop. You know, it's fine. It is not as good in my eyes as the for loop is, because you have more control with the for loop. I guess it's a matter of choice. But again, this video series is not a full 101 learn to program everything in Java. There's so much of that on YouTube. So this is basically for you following an academic program. So what I could say here is that our initial value is 0, which is fine because the 3 names are stored in the archives of names, and the first one, actually think about the archive as, let's say, a shelf, and you have 1, 2, 3 storage spaces, and the first one is not called 1, it's called 0. That is just where the computer starts to count from, 0. So that's the answer for why it starts from 0. Nothing more than that, nothing great, no real anecdotes or something. It's just where the computer starts to count from. But and the next one will be like, this is 0, let's just write it like it's called the index, just to give it some name now. 1 and 2. So if we go ahead and say that we can start from 0 and we can go to as many there is size, so the size of this would be 3. Now I know this is really confusing now, because let's just, you know, make a multi-line comment and comment all this out and do some explanation. We're gonna print out to the screen the size of this archive now, and I'm gonna run the program. What you will see here is the size of 3. Now whenever you ask for a size of something, you're gonna get that in human readable understanding numbers, or just human readable numbers, HNRs, which is 3. That is 3, 1, 2, 3. But we also have 1, 2, 3 here. It's just the index of it. So yes, we have 3 of them, and you can see a shelf with 1, 2, 3 positions, but which position will you ask for to be precise to make sure you get Julia? And that's going to be 1. Alright, so now we can say that if this is actually 3, it's going to print. We can remove the multi-line comment, and multi-line comment is /* and then whatever's inside, and then */, which is reversed. Basically that's it. So now we're gonna say we start from 0, go to the largest number of 3, and since our is 2, then it's as long as it's less than 3, it says. And if it gets to the number 3, it is no longer less than 3, it is not this will evaluate to false, so the for loop will not execute again. And for every executional iteration, we're gonna increment the variable of I with 1, from 0, 1, and 2. What we're gonna do here is gonna print out. I'm gonna print out the archive, and I think the function is called get, and you can get the index. Now you see that it's making some sort of sense, and you gotta put in the number I. I'm gonna run the program, and basically you will see the 3 names in the console. So what you can do now is say, okay, so now you can loop through all the values. What if you accidentally, you know, try to access one of the indexes that was not indexes, I guess it would be in Perl? Then it will give you some sort of exception, probably, or an error code. Let's just try that for now. Let's say +1. So now it's going to try and access index number 3. So you'll see down here, it's going to say something like index 3 out of bounds for length 3. And it kind of makes sense if you think about it, like index 3, so index 3, we have no index 3, out of bounds, it is out of, you know, bounds, I guess that would be for length 3. So basically it's saying the length 3, as we discussed before, human readable numbers, and the index. So human readable numbers and index is not equal. Equal is to say index 0 is the same as 1 in human readable numbers. It doesn't make sense. So you need to get your mind that way. So basically that is an exception. It's basically it's telling you the 3rd or the 4th position is not present. So what we're going to do now is basically just run the program again, verify it's running, and we're going to do some conditional here saying if, and this is going to be a search function. We're going to create a search function now. If get I dot equals the name of Julia, then we're going to say we found Julia. can run the program pretty fast just to see what it does. And we says we found Julie. So what really happens here is basically like, I'm going to say if, that is the start of the conditional statement. So we're going to get the archives of names, ask for whatever index we are in the loop, and the first one is 0, so this is going to be Daniel. Is Daniel equal to Julie? No. Then we'll not print this. Next time is Julia, so is Julia equal to Julie? That is true. Then we're going to print we found Julia. So what if we wanna add some sort of way to, what if I ask for Bob and I just run the program? We get no success or no error code, so we would probably not be that, you know, popular in the business where they use this program, because we didn't really supply them with a reason to why, you know, Bob was not found. So what we could do, basically create a variable called boolean, and then you can say user found equal to false, and if we find the user, we can inside of here set it equal to true. That is one way of thinking, that you use this variable as some sort of state variable. So you're setting the state to false to true, and then at the end you can create another conditional down below here. Now it gets a bit big now, so it says like user, if that is equal to false, then we're gonna print out the user you searched for was not found. And basically, if I run this program now, you will see that it says the user you searched for was not found. If I then again search for Julia here, run the program, then you're gonna see that this statement is just gonna say we found Julia, and this will not print out anymore. So this is like a default way to catch the, oh, we didn't find anything in the system. That is the way, you know, this is the way you're gonna code it. So this is loops basically, and I demonstrated how you loop through something called an Arraylist. An Arraylist is just an array of values. In this occasion, it's gonna be some text strings. So, but you should be able to, you know, if you're gonna say that, okay, so I'm gonna mix in like a 0. Can I do that? Well, yeah, you can do that. It is not, you know, against the syntax or rules of Java. You can mix any types in the type of Arraylist. Now pay attention to when I say type. I say type a lot. This is a type. That is because in Java and object-oriented programming, usually what you call these things here, like Arraylist or bool or int, is a type. A type is something you're gonna work with. It's a type of it's like a toolbox, but not really. It's like if you have different kind of card boxes, you have a box made of cardboard, you have a box made of iron, you have a box made of wood, you know, and so on. That is a type of box. So depending on what material it's made of, you can use it for different purposes. And the same thing applies to Java. Basically, you know, it's not that easy just to explain. All right, so I think for now, we covered for loops. We talked about how to create a search function, and we did like if we didn't find anything, we have one thing left. That is this here. So that is a literal value. One more time, we are trying to get away with that. So we're going to create a string called search for, set it equal to Julia. Just like that, and search for is going to be replaced with the literal value, and instead of that we're going to use our concatenator and put that in instead. We're going to run the program one more time to see that we found Julia still. If I now write Louis, you will see that it says we found Louis. So basically that is a way for you to make your program more dynamic, and this is what the teachers will ask you to do in the school. They're going to ask you to make more dynamic code. And the way of doing that is to use variables to store values in, and reference those variables, or call them, or use them, or work with them, you know, in this way that I did right here. So this function here is, well, this algorithm, basically that it is an algorithm. It's basically saying that, you know, we're gonna search the whole list, loop through every single index inside the list, look for all the values, and ask if whatever is index we are standing on. Gonna ask if we are equal to the word that is inside the string, the letters inside of search for string variable. And if it is equal, then basically gonna say we found it, and we need to do one more thing. Do we need to continue to loop through all the values? If we look for Daniel, for example, we will still print out. Let's do one here. Let's do a this is not print line, and then we're gonna create a dot, and you should see 3 dots in the output here. See, we found Daniel, 1 dot, and then 2 more dots. So you also executed Julie and Louis, but no reason to do that, you know. So whenever we're done with that, basically you're gonna write break. Break is breaking out of the iterational phase we are, this for loop. So we're gonna run more time, and you see we only have 1 dot now, and we found Daniel, so we save the program some executional time, which is also what the teachers will ask you to think about whenever you're gonna use loops. So I think for now, take care, see you next time.